welcome back again to another video. And in today's video, we're going to be going over two different SIEMs. One of them is going to be Security Onion, and the other will be just a straight up Elastic stack, just running Elastic and Kibana. And particularly what we're going to be doing and going over and looking at is trying to find out whether or not if one SIEM offers a better alerting solution than the other. I'm pretty familiar with Security Onion and how to get various sets of data into Elastic and use it with Security Onion, especially like the newer version. Also with Elastic, just straight up Elastic here, you can see that they have a security enterprise solution, and they have what is called the Elastic Agent. Some people may refer to it as XDR somewhat, but essentially it allows you to gain more telemetry on an endpoint, network logs, host logs, some more advanced threat detection capabilities using rules that kind of like are really interesting in a sense, because it reminds me of like in-game, Elastic acquired in-game and whatnot. So there are two different things that we can do when it comes to testing out whether or not which SIEM is more fruitful. We can do like static testing, or we can do a more like live dynamic test with, let's say, like a C2, like PowerShell Empire. PC Security maintains that, or some other kind of like C2 framework, kind of mimic some adversary actions, and then see what we see in the SIEM, like Security Onion or Elastic, just seeing which one's better, right? Maybe not which one's better, but which one's more like user-friendly when it comes to alerting and creating cases, and then tracking down, all the way from the root cause of the issue, correlations and things like that. So let's go ahead and get started. And the best thing to do to test whether or not which SIEM offers a better solution, they're both Elastic, but they have different capabilities, is to go ahead and let's do some injects, right? So if you're not familiar, I'm using Proxmox. You may be using VMware or some other type of like hypervisor setup. I'm just managing everything through Proxmox, got it all segmented and networked out and stuff like that. So here I have what is Empire, right? And here's the server, started up, and here's the client, okay? And they also have Start Killer, right? So you can log in, it's Empire admin, and there we go, right there. And you can have your listeners and create stagers, and here's your agents when you get a callback right here. So let's go ahead and do something on an endpoint. We'll choose this guy's Windows endpoint right here, and go ahead and open up our viewer. And let's just see here, we'll run it as just regular user. Downloads, nothing there. Go ahead and pull this over. Our stager is a service host, exe, right? And we'll go ahead and pull that over, see what happens. Now, if you have Elastic Agent on your endpoint and it's acting as your antivirus, you'll also see, depending on what mode it is in detect and prevent, you'll have an alert, right? And you can enable Elastic to take over as your antivirus, which is pretty cool, right? So Defender is taking a back seat for this one, and it's Elastic that is doing the deal. So let's go ahead and run our inject. And as you can see, PowerShell interaction there. And let's go back over to our SIEM, or excuse me, our C2, and see if we had a callback, right? And as you can see, we do indeed have a callback. Now, we are user administrator, but we are not in a elevated context And what I mean by that, we're not in an elevated process or a high integrity shell or so-called session to do things like dump creds or create persistence and stuff like that. So we may want to figure out a way to elevate privileges in a sense into like an elevate our status on the box, right? So let's see, first and foremost, here's our agent. Let's go back. And actually it does look like we are in an elevated process, probably because we ran it as administrator. I've seen instances where, you can run something, and even though you're administrator, you still may not be in an elevated process. Nonetheless, we could still do some injections and stuff like that, right? It's just too easy. So let's go back and actually look here at security unit and see what we saw, right? So nothing just yet. Go over here to Elastic. And we do see some alerting right here. And we can view alerts and scroll down, close analyzer, and see that we do have some alerts here. We can look at the first one. And we see command.exe, ran service host.exe, and PowerShell was involved. And conhost.exe is the running process, probably for connection purposes. So this is actually pretty cool because you have this all in one quick shot from the originating process to the actual process that's being analyzed, and then PowerShell, and then you can probably click here, and then you'll be able to click on this little community ID thing right here and see that this is our C2 over 443 that's connecting back to. So that's pretty neat. That was pretty quick to determine, hey, we got an issue here. And you can actually go back, view alerts again, and go right here and do more actions, or actually let's investigate in timeline. And then let's modify this and new malicious process. All right, there we go. Cool deal. Let's go ahead and save that. And we can create a new case. So attach to a new case. Let's see, we could probably call it a new bad process. Right, and then give it all kinds of like other tags and stuff like that, like malware, right? And let's go ahead and save it, create the case, and there we have our new case, right? And we can click on that and go back and actually go back to the log and take a look at it a little bit deeper if we want to for later analysis. Okay, pretty cool. That wasn't too painstakingly hard to do. And these rules right here, excuse me, are all under the rules section, and you can look at them and have more granularity when you're looking at things such as command and control, or if you want to look at execution, I believe. Let's see, or defense evasion, or discovery with those tags, and look more deep into the rule to see what the query is, and also ties it to a nifty little MITRE attack TTP. And if you're not getting what you're looking for out of the pre-made rules, you can go back and create a new rule, and then go from there, choose your index, create your custom query, and keep chugging along, right? If you're not seeing everything you want to see up front in what comes out of the can. So interestingly enough, we have some more alerting. And before we go any further, another really cool piece of information is the network piece. So there's not a sensor that's sending logs to this stack. Actually, it's collecting network data from the endpoint itself, so straight from the source. So it makes for easier correlation and pivoting and stuff like that. As you can see, we were able to get an alert from some malicious activity, and then pivot to a network log, and we saw what the C2 was. It's as easy as that. And so when it comes to managing these endpoints that have Elastic Agent on there, you do all that through Fleet. And Fleet's pretty cool. There are a few other things you can do with Fleet, such as agent policies. So if you have like a sensor that you're getting data from, you can create a policy and tell it to, hey, look at this directory right here and gather all this NSM data or Zerikata alert, stuff like that, and push a package to it to manage it as such from Fleet inside your Elastic Stack. Pretty cool. Or if you have your Windows environment and you want to manage the packages that are on your endpoints, you can do so as well from here, from Fleet. Pretty cool. You can also say, hey, look, I want to do a new Windows integration policy, and I want to say I want to collect certain events or metrics. You can do that as well and get more granular if you need to. So it's from a central location, from an Elastic standpoint, having Fleet and then being able to have the ability to push these packages to the endpoint and say, hey, I want to now start grabbing this data. That's actually pretty cool, unified solution, so to speak. Let's see what else. So let's go back to overview and look at the alerts that we saw right here, right? So we have malware alerts, we have unusual parent relationship alert, malicious behavior, binaries masquerading around, and it all seems to be correlating around this service host.exe. So let's look at this first one. And we have some sort of a terminated process at Chrome. Let's look at the second one. Here we have the one that we saw originally earlier right here. And you can also see what other libraries it touched. And if you want to dig down a little further, get some more granular information to see what all this malicious malware may have done and touched, you can look at that way. And then here's another alert about service host masquerading around. So kind of the same thing, but different alert, right? And unusual parent-child relationship. So doing its, I guess, threat detection. It sees that this should not be the case. So it alerts on that, pretty cool. And if we wanted to, we could say, okay, let's analyze event or add to an existing case. We can add this to our new bad process case if we want to, and then go from there. And then view our cases as such, new bad process. And then we can see that there was some additional information added. And then it'll take us back to the rule if we want to look at that. Or if we want to, let's see, expand out and read more about the EQL rule, or look at the actual alert, we can do that, and the log, and go more into detail there, pretty cool. And take action. We can actually isolate the host. So that kind of is like a really powerful feature there. Let's see if we can actually, let's go to isolate, and then isolating it will disconnect it from the network. So if you're absolutely sure that you want to isolate the host, you can do so. But let's not do that right now because we still have some more things we want to do, right? So we'll go ahead and exit out of here. And let's go back to our security onion and see what we have. So we have playbook rules enabled and Security Onion that work in tandem with Sigma to analyze Windows events, and then we'll alert on if said selection or action meets the condition, and then alerts, right? So this one right here, I've had a lot of false positives with. If you want to go ahead and disable that rule, you absolutely can. It's active, number 183. Edit, make it inactive, and then submit. So there's that right there. Let's go ahead and exclude it here. And let's go ahead. Let's go back and then alerts. And let's see if we have any Zerkata alerts. Let's refresh this real quick. Oops. Yeah. Let's go here, refresh. So let's get rid of this, exclude. And so we have remote PowerShell session, Empire PowerShell launch parameters. And then we also have PowerShell network connections and so on and so forth. If you wanted to do any correlation, let's see right here. Let's drill down and look. We have our C2 as well. And we see that it's making PowerShell connections over port 443. If we wanted to quickly correlate and pivot to anything else, we can go to hunt this particular destination IP and look and see that we do have Zeek connections, as well as some sysmon logs and some playbook rules that are alerting. So this will kind of help us say, okay, everything in a nutshell, what do we have that's actually connecting to it? Not just host-based alerting, but also network activity as well. So you kind of saw what we did on the Elastic side of things with using XDR or the Elastic agent. Now you're seeing how we're doing business with Security Onion as well, and correlating all those data, event modules and event data sets to get a more robust view of what's happening, right? But this isn't the smoking gun that you would see, okay, so we have a connection, so what? Well, let's go back and look at suspect service host activity or suspicious service host process, system file location anomaly. So let's take a look at that and drill down. Go here, we have our host, and we have a rule name based off our sysmon config. It's a hitting on event viewer bypass UAC, but not the case in this particular instance. But this is telltale information right here. We have no file version identification, no description or product. It's a service host.exe. We see service host a lot on Windows computers, but we don't particularly we should not see service host executing from this directory, unknown binary at this point. So what you could do is you could escalate this to a case, and we'll go ahead, and we did one earlier, but we can do a new one. And we can go look at our cases, and we can say this is the newest one right here, and drill down. We can go to observables, or excuse me, events. Go down here. Here's our original alerts. Let's add some observables. So we'll do add new observable here. Tag it green. Add yes. Go, and then we'll have our hash right here, which we can hunt off of right here. But let's go back and add some more information. Here's a host name. We'll go ahead and add that to an observable. Yes. And add. So now we have a host name, and now we have some hashes related to this particular binary that we're more concerned about. And let's go back one more time and add our service host .exe as an observable. It's not a false positive. Green. Add yes. So you see how easy it is to just quickly add observable after observable after observable. I think this is probably a little bit more easier than Elastic alone. I find it a lot easier actually. And we can actually just go and quickly just pivot back into the logs and hunt these particular hashes. And here you can see they're associated with some different information: process creation, image loaded, create file stream hash. So we could click on that and include. We can go to our first log that we see, and we can see that it most likely came from Chrome download, and that would also probably be added to the originating factor of like how it got on there, right? Let's go back to cases and drill in, look at the events, And we can see right here we have what we need. We can also add network logs as well. So if we go and we go back over here, alerts, PowerShell connections, and drill down, and then look at this particular C2. Go ahead and begin our hunt. And we can add these particular pieces of information to our original case, right? Boom, I'll go ahead and add that. And connection log, that's a lot of them, right? And maybe a notice right here. And go, and so we have all that, right? So pretty cool. Just keep adding to our case to see if we can make it as robust as possible. All of our events, so on and so forth. So let's try something different. Let's take it a step further. We have our initial access. Let's see if we have any new alerts over here. I don't see anything else. So let's go and back to our Kali. And it looks like we still have a beacon. And let's see if we can inject. So we can do it through Starkiller, but we can also do it through here. So let's go ahead and interact to our agent. And let's see here. PS. So we'll go ahead and see if we can list services or anything like that that's running processes from the endpoint, and see if we can get any of that data back, and see if we can inject into a process, and then see if we see that in the logs as well. So let's pick one that's prevalent that we might be able to hide on. Let's do con host. Service host, we're already service host, so that would look weird. Yeah, let's do con host, right? Where was that at? I just saw it, 2196. Okay, con host 2196. So let's do use module inject. Let's do PS inject, right? And we got that set. So set 2196, or excuse me, we set the process. 2196. Then we should be able to execute now. Oh, we got a set listener. HTTPS. Execute. Okay, so we have executed the task to inject into con host on process ID 2196. And it looks like the task carried out. And let's see here. Go to Starkiller. And I wonder if we can spawn a new shell or a new beacon. So we injected. Let's let that carry out just for a moment. Let's see what we got. Let's go back over here and let's start with Elastic first and see if we find any new alerts. Let's go ahead and refresh. We do have one right here, but it has it for credential dumping. Interesting. Let's look at the details table, and we'll actually see the entire log right here. Let's scroll down to see if we can find. So we see PowerShell image interacting with LSAS. And this is a rule that I created. And we look and we see PowerShell is indeed interacting with LSAS, which is probably not something that should be happening regularly or at all. So we can either take action and add the rule to the exception or add a case. Let's not do anything just yet. Let's see if we have any other additional information. Nothing yet. Right there. Let's go back to alerts. And let's see if we find anything else in here. credential dumping tools, remote PowerShell session, launching parameters by Empire. Let's go ahead and exclude this. And let's take a look back at our C2. And yeah, there's that. And Elastic Alert will run every few minutes or so. So it may take just a minute to get any new alerts here. So let's see, got that. Oh, and if you want to see all your endpoints, you can just look at your endpoints through here. They are not offline. Weird. Okay. Hosts. There are hosts. And we'll go here. Complete. Yep, everything looks good. So might just be a little bug. Let's go back to overview. And let's drill down 15 minutes. And here we just have the one credential dumping alert. Could be a benign process doing something, I'm not sure. So we do have some more alerts in Security Onion, pivoting back over to Security Onion. And we see suspicious thread, remote thread created. Let's go ahead and drill down on that one real quick and see if this is indeed our inject. And it looks to be it is, because I see conhost, PowerShell conhost. And I wonder if this is the process ID. So I see the PID. Start module, interesting, interesting. Here it is, yeah, target process ID 2196. So this is indeed the first start of the process injection log. So it looks like Security Onion caught that using Sysmon, Sigma, playbook rules. Let's go ahead and escalate to our case and take a look at the other rule that hit. Same thing, looks like a little bit more information though. Actually, not so much really. Target process good, okay. New thread ID, so we have that as well. Let's look some more. And new thread ID, start address right here, interesting. So let's go ahead and take that and add it to our case. Look at another log. Some more start address stuff. So yeah, definitely suspect for sure. That is what we were doing. Let's see if Elastic caught it. And we do have some memory threat detection alerts, some shellcode. So let's drill in here. And we don't have this particular field, so we might not be able to see exactly all the goods. I'm not an Elastic engineer, so I gotta look into this and see what the deal is, but we do have an alert, right? So we need to tune that a little more. Okay, cool deal. So let's do some persistence and see if we can catch that, all right? And okay, all right, cool deal. So let's do this. Come back here. And I wonder if we can interact. No, we're still with this agent. Okay, so let's use module. Let's create a new user, right? So let's do admin user, okay. Use plan, schedule tasks. Sure, let's just do that first, right? And let's execute, see what has to be set. Set listen, okay. All right. Execute, name, script, and is not defined. I don't know what that means. Let's do a registry key one, right? And let's use module. Actually, let's see if we can dump creds. Let's do mimikatz. And let's do LSAS. And then set username, administrator, and then execute, right? And valid agent name, set agent, which is, I believe, was this one, yeah. Execute, okay, cool deal. So let's see if we can dump some credentials. Go from there. Let's see what else we got going on. Security onion. So this module, let's get rid of that right there. Oops. So yeah, we're just trying to show, or I'm just trying to show some functionality between the two. What might be best now, we're not getting any Zerkata alerts because this is all encrypted, so it can't see what's going on. So that's a bummer right there. Looks like we were able to analyze the events, and it's hitting on who am I. So whatever this rule right here, or this alert, oops, sorry, go back real quick. Darn it. 10 minutes. The who am I process. It's bigger. Yeah, we still can't see that. That's kind of weird. Don't know what's going on with that. Let's go ahead and minimize this and do 15 minutes again. Memory threat detection alert. Yeah, we gotta look more into that, what the deal is. Looks like local account discovery command has hit. So let's take a look at our, did we have any successful dumping of the creds? Come look right here, tasks. I bet mimikatz ran, but maybe didn't give anything back. So yeah, it did, just to get hashes. I wonder if we still get hash. So well, let's see if we can actually determine whether or not Security Onion did indeed catch Empire doing what it was doing. Let's get rid of this, exclude. Oh boy, wrong one. Let's do this. This is benign right here. So let's go ahead and exclude this, which will be getting rid of this, exclude. And let's go down here. So we see PowerShell and LSAS. So this right here would definitely be a telltale sign that we need to look out for PowerShell interacting with LSAS for whatever reason. So we'll go ahead and add this to a case here. Our next one is Elastic Endpoint, benign, and that's a known good. Go ahead and exclude. It looks like we only had that one instance of LSAS interacting with PowerShell. And it looks like we have some more alerts right here. Let's look at these two. And open up our window. Credential dumping right here as an alert for credential dumping that I made myself. And here we have this one, which we can't analyze because we don't have that, I guess, that parse event field, not exactly sure. So we are getting alerting on both ends, right? Let's go back to alerts and Security Onion. And yeah, so let's see if we can lay some persistence. So let's go back here and let's do use module. We'll just head this off the last one, right? Registry. And elevated, yes. And it looks like we need to set listener, yes, We execute set agent, and this one execute, and here we go. So let's see if it actually successfully lays the persistence in the reg key location. And we'll go here. We see our task kicked off, and it looks like it laid it. And current version debug, right? We have that. And let's see if we have any alerting. Nothing yet. Let's go back here. And nothing just yet. Let's see, non-interactive PowerShell, Empire Stager, suspicious remote thread. Remote PowerShell here. And there, let's go ahead. Do we have anything different? No. Here, not yet. And let's see. Oh, nothing at all. If we don't get that, we can also go in Kibana and look around. And let's go back to Hunt. And let's drill down into this. Include. Let's look at this. Oh, it's just his own identifier. It has a URL reference right here. Oh, that's pretty cool. Let's go back. I don't know where I was going. I'm on a weird tangent there. And nothing new that I can see. Nothing new here as well. So I don't think we actually caught persistence being laid. Yeah, quite interesting. Remote PowerShell session. Obviously, it's not good. Here, nothing that I can see there. Interesting, interesting, interesting. So we should hopefully, if we would have found an alert for registry keys being modified or something of that nature. But I don't see anything in the alerts section for Elastic XDR. And surprisingly enough, I don't see anything here. So we may have to give it just a moment. But let's do something real quick. Let's look in Kibana and see if we can find that manually in Security Onion. I think it's going to be something like, let's do last 15 minutes. And I think we're probably going to want to do, I can't remember the field off the top of my head. It's like registry field, so task, no, path, it's path, log path, no, it's not it either. Well, I don't want to do this, but log car search set, debug, here it is. And I was looking for a particular field. Here you can see that. Target object. Target object. That's what I was looking for. Let's go back. Target object. Here you go. Okay, so here we have debug, and if we look a little bit closer right here, we want to details. Okay. Details. Let's do that. Okay, and that's a quick fire way to look at any registry key pass and then see what the details are. So there's that, and I'm sure it could probably do the same here in Elastic EDR. But if you look here, we do have some more alerting from the agent that's on there. So start up or run key registry modification and some shellcode. So here we have this. We can't, I don't know what's wrong with this process, event category process thing. I have to look deeper into that, but we are getting alerting there, so that's pretty cool. Let's look at this, and here it is. So we do have auto key run modification, and drill down, and there it is, our persistence. So with that being said, we can add this to our case, and then go back to our cases and have a better look at everything. And if we go here, I think this is going to be this one, perhaps. Yeah, so we can add this as an observable if we want to. And here, and then add, and there we go. So with that being said, we definitely got a good feel for both SIEMs, Security Onion using Elastic on the back end, and then straight up Elastic using the Elastic Agent endpoint with some really cool features. You can do the trial version and see how you like it. But overall, I was trying to give you kind of like, hey, let's do some injects. Let's see what they look like in the logs. How user-friendly is it? We could go into depth and make queries and analytics and stuff like that, but this is more or less like out of the box. What can we see just with some low-level basic stuff, right? And I hope this was a pretty cool video. I can do some more, and let me know if you want to see more. But until then, I'll see you guys in the next video. Take it easy.